asking you to give us a couple of practical examples of how AI is being used in agriculture today, and if you had to pick one that has given the biggest boost to business so far, what would that application be? Jim, do you want to start?
Sure. So we use AI and machine learning across all aspects of our pipeline, from research to supply chain to commercial to what we do with growers. And we have digital agricultural tools for growers that actually is AI enabled. How much fertilizer to put in the ground, what's the best water and irrigation they should apply, how to precision plant. So we can actually precision plant each individual seed, depth and density based on a field map and a topology and what you're putting on the soil to actually improve outcomes. So if I think about R&D pipeline advancement, we do billions of simulations, use machine learning models to pick the best genetics that'll have the best phenotype. And a phenotype would be things like the best root structure or the best leaf that it could have or the best uptake of water. So you're trying to pick genetics of a corn plant, a canola plant, a soybean plant that will work in whatever conditions it's going to be planted in. In supply chain, we do things like managing, we grow all of our products, and so we use machine learning models to actually take acres off in our production. And the way we do that is we look at how that seed is going to perform in that particular piece of soil, and when you plant the male and the female to create the hybrid that the grower is going to get the seed, we can optimize that, and we can take thousands of acres off based on a machine learning model based on how to plant it and when to plant it and the timing. We do a lot with logistics and how we do distribution. We also do things like forecasting of safety stock. We never want to stock out of a seed, and it's not like you can turn a manufacturing plant on if you want more of that particular seed. You got to forecast it. On average, we plant 5% extra safety stock in case so we don't stock out. We've been able to use models to get that down to 2%. That's significant dollars in our cost of goods. It actually drives sustainability in the resources that we use, and it allows us to continually evolve our platform so that, again, for a grower in our digital ag tools like Climate, we can give them precision planning information that optimizes their outputs while minimizes their inputs.
And if you had to pick one application that's given you the biggest boost, what would you, economic boost?
I think for our growers, it's probably our Climate platform that gives them real-world insights. They can map their field. They see how they're performing throughout the whole season. As they're pulling the harvesting off the combine, they see density, they see pressure, they see humidity, other things that are going on in their farm, and that gives them real insights of how to optimize their farm, and that's what we're about. We want to help our customers reduce their inputs, maximize their outputs, and do that as sustainably as possible. And that platform packages all that knowledge we have around seeds, the germplasm, the genetics, the chemistries they may need to apply, fertilizer, water, and gives them a personalized script, if you will, personalized medicine for the farm.
Mm-hmm. Excellent. Caleb, when you look at the landscape, I mean, there are just several that were just mentioned. Others that you're tracking or ones you would like to highlight in terms of AI's applications to agriculture?
I think most recently I've been pretty interested in the ability to take, go beyond yield and start looking at those phenotypic qualities that you were discussing, biochemical creation in plants, which leads to flavor, which leads to nutrition, mechanical advancements. So I have a project right now where I'm using AI and machine learning plus control environments to optimize cotton to see where would we plant it to get the longest fiber, the most uniform fiber, the most inherent pigment, the strongest tensile strength. Like we can start to run those models and predict and then say where in the world do those conditions exist? And if they exist there, then we should plant there to get that ultimate outcome that we're looking for that's now beyond yield. Mm-hmm. And it can take into factors now, what's the microbiome of that plant? What's the soil type? What's the nutrition in the soil? What's the air atmosphere? How much light is available? What spectrum of light? For how long? And then we've never really been able to do that before with all of those variables. We recently started training a stock trading AI, one that's trading in milliseconds currently now autonomously on the stock market. We started making it make trades for all of our inputs, which include the things I mentioned, optimized against a single biochemical output. And in our case, we were watching a flavor molecule that we were interested in to make a kind of hyper flavorful basil. And so as we start to learn through that, we also discover new things about plants, like different biochemical responses, different defense mechanisms that we can engage to create and use the plant to produce the thing that we're looking for.
How much, the penetration of AI in different sectors depends a lot on how advanced they are in collecting data. How much groundwork had to be laid for companies in the sector and for farmers to really be able to embrace AI? Were the platforms already there? Was this an industry that had to completely build everything from the ground up? Caleb, do you mind taking that one on?
Yeah, that would depend on who you were, right? If you started as a pharma company, you probably had a whole lot of data that you were already sitting on to build these kinds of
in
models.
agriculture.
Yeah, in agriculture,
Yeah.
Agricultural products becoming pharmaceutical products, nutraceuticals. And obviously Monsanto would have a ton of data from a lifetime of optimizing plants and doing amazing work. But if you're on the other side and you're coming out of discipline, which is me and the folks that work with me, you have to start creating data sets because we just don't have access to very large, very well organized and tagged data sets where we can immediately move into machine learning AI. And I think that's where I put a lot of time right now, which is building the capacity of people around the world to create a data farm so that we can use these advanced tools. And so that's giving us kind of the ability to move it out of just the plant sciences sector and into other ones.
Okay. And Jim, how much of a kind of a strategic change needed to happen as you were thinking about integrating AI into your operations and decision making? And what was the groundwork?
It's pretty pivotal to us. We've been capturing data for some time. It's layers of data. So think about soil data, germplasm, genetics, microbials, what's actually in the soil, how that performs, water, et cetera. So you think about the layered set of data. How do you best apply that to make the decisions? What do you promote in your pipeline? Because think about us as a research organization. We have products we need to move through a research pipeline. So which ones do you promote? Which ones are going to be good in a certain condition, in arid conditions, in very wet conditions, in maybe colder conditions, et cetera? And every decision we do, we try now to tie it to a model. So I actually measure how many how many business decisions are tied to models. And we started with very few. Like, for example, we do simulations of what seed to promote in silico before we put a single seed in the ground. We're at the point now that we have over 100 decisions that we apply models to, and it could be, again, my supply chain logistics. It could be the hybrid to promote. It could be avoiding customer churn. It could be how much fertilizer do I put for a grower. We have over 200 models in production, and a third of them now are machine learning. So we've moved from regression-based, statistical-based models to now machine learning-based models, and hopefully then we'll evolve to deep learning. But we keep on getting more data to feed that to get more precise, better insights, and that will help us get better products where they needed, when they needed. Since you start with a pharmaceutical example, when pharma companies develop a drug, a lot of times it's a broad-class therapeutic. They're hoping that they hit as many people as possible and not having a negative impact for safety. But now they're trying to do personalized medicine. We're trying to do the same thing with farming, personalized farming. So I know that growers feel what's the right prescription for that farm, the hybrid, the water, the nutrients, the chemistries. We take a lot of imagery data, et cetera, that actually best support what they need to do. And again, sustainability is really important for us. How do we do that using less resources?
And if I could jump in.
Please.
I think if you just heard the two of us talk and you realize how many disciplines are involved in the data sets that we're working on and how broad that is, I think it would be unreasonable to assume that one company, one group, one lab could ever produce enough data to really make super meaningful use of advanced machine learning in data. I mean, that would be like saying one lab did the human genome, and we know that's not true. That was 10,000 researchers, that was billions of dollars, that was a common understanding that we were going to create a civic asset so that we could derive civic value. And I think that's what we should be talking about in ag right now, is who has access to the data, who owns it, who's willing to give it up. I mean, we have people now that are giving up their genome data just for science. Mine's in George Church's hands. He's looking through it to see what's wrong with me so that he can see what's wrong with everybody else. And so as we talk about data and building it quickly to use tools that are now existent, we need to also say that that's not a process that's going to happen alone.
Okay, and so this goes also to the question of who owns data, correct? And data sharing. Can you talk a little bit about how the industry is thinking about incentivizing data sharing and ultimately who owns it? And Caleb, can you begin on this?
I'm like the anarchist for that question. I mean, I took all of my work open source at its inception of the lab, and that you might think that would mean that I don't have any corporate sponsorships. but it'd be totally wrong. I'm actually fully funded by corporate clients, and that's everything from the world's largest cotton manufacturer to one of the largest candy and confectionery companies to one of the largest retailers in the United States. And you'd say, well, why would they fund an open source project? And that's because the retailer doesn't own the supply chain, but it really needs a good one. And it really needs to be able to do prediction, and they really need to know quality ahead of time. You know, the candy company doesn't own hazelnut trees that make their finest chocolates, but they're having a hazelnut blight right now, and they need to promote knowledge in that industry. And to promote it only in that industry or only with the folks they do research with, it isn't moving fast enough. And so I see from an industry perspective the insight and understanding now that big data means big data. Trillions of data points, hundreds and thousands of training slides, and so they're making moves to add things to their supply chain, like spectrometers so that they can take lots of images, and then partner with networks of researchers to produce all the other information, like we were talking about the metabolomic profiles of the plant, the sequencing of the root microbiome, all of this other stuff that they can't do.
Excellent. Jim, can you talk a little bit about incentivizing data sharing and how you overcome concerns about data ownership and your incentives properly being aligned with farmers?
So we started with, when we talk about our customers again, our farmers, our growers, it's their data. That was in our data privacy policy before we wrote one line of code. So this is your data. Anything we do with it, it's yours to use. If you return that back to us, we hope that in our research we get to better products and solutions for you, but minimally we want that data to be available to you so you can understand what's going on your farm with all the assets and information. So it starts with their information. If they agree that they'll want to share it back, then we'll take that data into our research engine to provide more solutions. And you know, we're in a world that we have 7.5 billion people on the planet. By 2050, it's going to 9 billion. You don't have any more arable land that you can consume. You have to reduce that, and you have to actually reduce consumption of resources to do it. And so we can't get there all by ourselves. We can't get there without making that data available so we can actually provide the best insights, and that's what we're really trying to do, coupled with really good science, coupled with really good agronomic practices, coupled with really good insights. So it's not just I have a digital tool, how do you put all of that together? And that's why we use the word integrated solutions, so the microbials, the germplasm, the traits, the chemistries you may need to use, the water consumption, et cetera. And that is really the opportunity I think that we can drive. And we've seen dramatic impact on improving the outputs, reducing the inputs, and that information, again, provided that you get grower consent, should be consumable so we can continue to advance that.
And how much pushback do you get from growers?
I think, you know, they're scientists. They, I spent most of my career in the pharmaceutical industry, and I thought doctors were tough. They don't believe anything you have to say. You know, you say, this is a really good hybrid, it's really going to perform well, so that's nice. I'm going to try it in this little strip plot over here, and if it doesn't work, you know, I'm not believing you ever again. So, I mean, they know their business. They are amazing professionals. They're agronomists. They're good people and family-oriented. They really care about the earth. They care about what they do and how they do it. But they want to test and learn everything. And they're a perfect group to work with because you're constantly iterating with them. And if you could show confidence and trust in them, they will, over time, trust you. But if you don't honor that, you will lose it and you'll never get it back. So you really got to be understanding of their needs. You got to show value to them. And if they do, you know, you always have populations that we really want to advance this because we need the science, we need the technology, we need everything we can. And those are the people that we partner with, and then success breeds success. Mm. And then if we have a failure, we go back and we iterate and we learn. And that's why you need multiple parties and partners, because we can't do it all of ourselves, and we do work with a lot of partners to be able to evolve that and provide value.
Cool. So just don't, as long as you don't use Cambridge Analytica, basically.
I do not. No, we do not. Not that I know of.
Okay. One more question, and if we have time, I'll open it up to the audience. 5 to 10 years from now, what looks possible that's not possible today with AI in agriculture? Caleb.
You want me to go?
Yeah, you can.
All right. Well, I guess two things that I'm thinking about lately. One is the predictive ability that we have with, you know, not just predicting yield, not just predicting loss, but predicting quality of nutrition that we're producing and how it matches to a human genome. And we're going to really design that relationship. You know, right now we produce food that isn't always have the most amount of nutrition once it gets to point source. So you're not creating an optimal human. And we're really optimizing for 80% of humanity, which I understand is a big goal, kind of 20% of the effort, 80% of the gain. But as we now understand humans more, and as the human genome, I think the last one was $1,000 to do, so we can predict in 5 years it should be $1 or so. Like, as we get that level of information, we can start pairing individual nutrition to individual consumer to the field that grew it and why it grew it that way. And that if we need to edit the plants to produce that relationship to make it stronger, then we absolutely will have the chance. I have a project that's just beginning right now between me and George Church at Harvard and another network scientist, where we're literally looking at, can we create diabetes basal? And that means basal for people that are pre-diabetic, in diabetic stage, to reduce that, or heart disease basal, or heart disease to manage. And so I think as we move into this more described future, if there are common assets that are built, they can also be leveraged by the medical community, by the energy sector, by a lot of different actors around the space.
Jim?
We keep on looking at how much data we can pull together that's finer grained, that gives us more insight. So IoT is big for us, sensors in the ground, looking at leaching of soil, having models that can predict that, looking at growth patterns. We use imaging from satellite to UAVs, we do infrared, we do multiple spectra. We continue to get a bolus of data that's giving us more insights to better optimize that particular piece of land. And it doesn't matter if you're a large agriholder in Brazil, or in the US, you have maybe 1,000 acres, or you're a small agriholder, less than an acre in India. We've actually been able to take farmers in India from sustenance farming to profitable farming by giving them early emergence of disease. They can literally take their iPhone and take a picture, and immediately right then and there they say, I got a disease emerging on this crop. What do I do about it? It's a call center. We can help them say, do this to treat your particular plant. It saves a crop. So whether it's large or small, we're going to continue to see a huge transformation. And then we think about from farm to fork. Traceability of my food supply, from where it came from what seed was put in the ground to all the way through to what's actually on your table. So being able to understand that, to be able to optimize that supply chain in an effective way. As this data becomes more available, these insights become far greater, and I truly envision that we'll get to a point that every single farmer will have a personalized script that optimizes the farm for all the reasons that we just said about sustainability, feeding the planet, using less inputs, maximize those outputs, and then do that in a very effective and appropriate way.
Hey there, my name's Emmett Hollier. I'm with Solstice. Question I have that's, I guess, specific to agronomy. Can you comment on the challenges of not being able to run continuous testing and gathering data just because of the nature of one growing season per year in most places?
Thank you.
Yeah, sure. So I would say, I mean, it's not that you can't collect ongoing data through that growing season, but I understand the question to be the iterative development based on asynchronistic variables, right, the outside. That's one of the reasons that all of my work is in control environments, and that might be a very specialized answer to your question, but it is because it's much easier and faster to use machine learning when you're controlling the variables. And you can do single variable isolation, and then you can take those single variable isolations to inform a model, and then you can run that model 100 times without having to grow. I think the goal is to produce high fidelity enough models that we're not limited to what we have been limited to do, which is every growing season and the slight change that we make in an environment that we don't fully understand, because no one understands the way that ecosystems truly function. And so I think, yeah, it's a limiting factor, but it's starting to be overcome through high throughput sequencing, high throughput phenotyping, the models that are being built off of that to get us out of that cycle.
I'll just add to that as well. So we grow all around the world. So Brazil's got 2 growing seasons, regular season and safrinha. And then wherever we grow, we're always collecting the information in our research plots or supply chain. So it's kind of our data lab, if you will. And now what we have is what we call real world evidence data. What's actually going with our hybrids? The growers are actually using it in their farms, being able to associate the data with our research data, continually adding to those data layers. And as we get more data layers and more fidelity in those data layers, it actually gives us better insight to continue to evolve those models. So we're getting the level of complexity built into the data that we need to continually mature in all different types of conditions that we may run into to optimize it.
I think before we end, if I could, I think it would be remiss not to look above this conversation and say, in AI, is there a value to being open, and what is the value? Why is TorchNet open? Why is TensorFlow open? It's because they need millions of people to interact with their system to produce a whole lot of data that they can do some kind of learning on. And I think we need to take that approach in agriculture as well. There's Monsanto doing amazing things. There's also other not a startup, there are startups around the world that now, one of them has more in-field data in the United States than the USDA has digitized in its entire history. It's only been active for a few years. So as all of these little efforts are going on together, I think we really have to say, how can we create an asset out of that? And how can everybody benefit so that we go from the $1 million human genome, whatever, 5 years ago to the $1,000 one today? What is the analog in what we're trying to do to that?
Excellent.